I'm back to my slide one. Can I go and start again? Okay, all right, okay. Good day, colleagues and learners. After just a glitch now, we can start with our today's lessons. It is expansion, contraction, and pressure. It is a topic that comes from the grade 8 curriculum. Okay, my name is Tisha Tsomuhutle. Okay, colleagues, for today's lessons, we need to highlight all the items that we need to talk about so that it gives us the formulation of learning in a sequential manner. Okay, for today's lesson, in order to understand the three concepts, it is very important that learners understand the following. They need to master the particle model of matter, which we are going to revise. And then I'll explain the concepts, expansion and contraction. Then I'll describe how solids, liquids, and gases expand. I will also identify everyday consequences of expansion due to heat. And then we'll also look at pressure as it occurs in liquids and solids. And lastly, we'll talk about the effect of temperature on the pressure of a gas. Okay, the particle model of matter is recited as the following. Learners should have already been taught about the model. It says all substances are made of particles that are too small to see. The particles have spaces between them. The particles are always in constant motion. The motion of particles increases whenever the temperature is increased. The motion of particles will decrease if the temperature is decreased. And lastly, the particles are arranged differently in solid, liquid, or gases. Okay, let me just go over the two concepts of expansion and contraction. Expansion, the particle model of matter, suggests to us that materials expand when heated, meaning they grow in size. When heated, the particles, which are either atoms or molecules in that material, will vibrate more. This means the particles need more space, so the material expands, then it grows in size. As you will see here, I've just given you an example of particles. There are about 16 particles on the left-hand side of that red arrow, and then you see on the right-hand side, the particles spread out, meaning the spaces between the particles is becoming larger as you heat a material. Contraction, directly the opposite of heating. If you cool a material, the following are going to happen. The opposite happens when most substances are cooled. The particles will move less or vibrate less. They need less room because they don't have to spread out the substance. Therefore, we say it contracts. You'll see on the right-hand side, the 16 particles were far apart from one another, and then the material was cooled, and you see the atoms, they come closer to one another. What is important to take note of are the following, very important. Expansion occurs even when the material does not change its state of matter. So learners should not confuse the change of state of matter as expansion. The particles do not increase in size or even in number. It is the spaces that get larger between the particles. As you will see above here, on the left-hand side of the arrow, there are 16 particles. They just move away from one another when the particle, the material is being heated. And then when it is being cooled, they just move closer to one another. It means the number of particles and the size of the particles does not change. What changes is only the spaces between the particles. Okay, let's look at how expansion takes place in solids. Solids cannot be compressed. Solids, when a solid substance is heated, as you will see the railway track here, on a very hot day, the particles of that railway iron track could not, they vibrated, but they could not leave the track iron. So it rather they bent the railway track. That is the effect of the heat, as the particles of the iron on the railway track are vibrating a lot. Solid substances expand to allow vibration of particles. So the bending here is actually what is referred to as expanding. So the iron could not expand to any other side. They had to expand sideways, but that could not happen, but it led to the bending of the railway track. The expansion of solids is very small as compared to liquids and gases because of the strong forces of attraction between particles. Okay, what about liquids? Expansion also takes place in liquids. Liquids, just like solids, they cannot be compressed. They cannot be made smaller than the spaces that are in a liquid cannot be made smaller than a particular minimum. So they cannot be compressed into a smaller volume. When the temperature of a liquid rises, as you will see here in a laboratory thermometer, the particles they can only move up. That is why the reading on the thermometer moves from 20 to 60. And move is because the particles move a lot more, causing the substance to expand. Remember, the liquid cannot expand sideways. The only escape for it to expand is if it moves up the column of the thermometer. Most liquids expand when heated. Okay. Then the next thing, expansion in gases. Gases are colorless and therefore difficult to observe. Gases can be compressed. Why? It's because they have very large spaces between the particles. So gases always take the shape of and the size of the container. Gases expand a lot more than liquids. You'll see on the left-hand side, you've got how many particles? 2, 4, 6, 7. The space is small. As soon as we make the space bigger, gases, they try to occupy all the spaces. And in that way, the spaces become smaller. They want to occupy the whole volume of the container. And in that regard, they move further apart. So the opposite can happen. It means it can be compressed. It can be compressed. The gas can be compressed into a smaller volume, or it can be expanded into a larger volume. Okay, let's just summarize expansion and contraction. It says here, as the temperature of a solid liquid gas increases, the spaces between the atoms or molecules of the substance increases, causing the substance to expand. That's number one. Number two, as the temperature of the solid or the liquid or gas decreases, which is the opposite, the spaces between the atoms and the molecules of a substance decreases, causing the substance to contract. Thirdly, expansion or contraction due to changes in temperature is not permanent, meaning something can expand when it is very hot, the material can expand, and then when it gets colder, it can then contract. Number four, the number of atoms or even the size as well, they do not change with the changes in temperature. What changes? It is only the spaces between the particles. Lastly, different types of solids, liquids, or gases expand or contract differently. Already it tells us that all the three states of matter can either expand or contract. But depending on the type of, if it's a solid, the type of solid that you are dealing with, it will expand differently from another type of solid. And then lastly, let's talk about the last two slides, pressure in solids. Pressure describes how a force is spread over an area. That is, pressure depends on the area over which the force is applied. Meaning, if the force is applied over a small area, there will be a certain amount of pressure on that surface. If it is applied on a very small area, there will also be a different amount of pressure on that surface. So number two, it is the measure of how much force is acting. That is, pressure depends on the amount of force. And then we can relate the two concepts here, force and area, to pressure in an equation. A pressure is equal to the force divided by the area. The smaller the area, the higher the pressure. If you divide by a bigger number, the resulting will be a smaller pressure. Now, the two diagrams that you see here, I'm trying to illustrate the changes in the area. On the left-hand diagram, we've got a sharp knife. It's a sharp knife because it's pointed at the end. It is pointed at the end. It is pointed at the end, and the other one is a blunt knife. Now, a pointed knife has got more pressure. It easily tear or cut the material that you see below in orange, whereas the blunt one will not be able to do it. Now, when we compare also a person who's wearing the stiletto heels or shoes with heels, sharp heels, and the one with flat shoes, if it is the same person, it means the person has got the same mass, meaning the same force on the ground, but the pressure of the heel is gonna be so strong, such that if somebody steps on your foot with a heel, you feel pain or even more pressure than if a person steps on your foot with a flat shoe, which has got a very large area. Pressure in liquids. This is just a summary. A liquid exerts pressure in all directions. At any point in a liquid, the pressure is the same in all directions. Pressure of a liquid increases from shallow to deeper level, as you see in the diagram here. If you were to put water or any liquid in a beaker and then you pierce three holes, the hole at the bottom would exert more pressure by show of the water that squeezes a lot than the other levels above. Pressure in gases. A gas exerts pressure because of collisions with each other and against the size of a container. The more the number of gas particles in a container, the more collisions of particles and hence the increase in pressure. Okay, the smaller the volume of the container, which is the smaller the container, or rather the larger the container, I think it was a mistake here. No, the smaller the container, I'm quite right. The smaller the container, which is equivalent to the smaller volume, it means particles are squashed within a small volume. They are closer to one another. There will be more collisions, so there will be an increase in pressure. So on the beaker on the left-hand side, it has got particles that are grouped into a very small space. They collide more often, hence more pressure, whereas the particles in the right-hand beaker have got more room to move, so they collide less often, so the pressure is also less. Okay, this is the last slide, colleagues, just a summary about the pressure. Pressure is a measure of how much force is acting on a certain area. Pressure can be increased in two ways. You'll remember, pressure is equal to the force divided by area. We can increase pressure by increasing force. It means force is it's a number that is above the division line, so it means the answer will be a bigger pressure. Or you can decrease the area of the force. It means you will be dividing with a smaller number, so you'll be increasing the pressure. So this is the formula that is used. Pressure is equals to force divided by area, which is used to determine the pressure of a substance on a surface. Fourthly, pressure acts in all directions in fluids or liquids. Number 5, as elevation increases, gas pressure increases, meaning the higher you go, then the pressure increases. Okay, but as for liquids, the deeper you go into the water, or the less depth you have in the water, the pressure would also increase. The deeper you get into the water, the pressure increases. Or as the depth in water decreases, the pressure increases. That comes to the end of today's lesson, learners. There's an exercise for you. And thank you very much for joining for this lesson. Today's lesson. Thank you very much.
Thank you very much, Mr. Makutle.
Yes, thank you, Dr.
To everybody, thank you for attending these lessons. This is now the last lesson for term 2. We will see you again in the beginning of term 3. We will continue the VLRP lessons. Good afternoon to everybody. Goodbye.